All right, so this is R1. I said it yesterday, but I'll remind you that this is not in your textbook. Remember, we downloaded chapter 1 yesterday. This is supplemental to that stuff. So your resources for R1 and R2 are going to be the notes I give you, the warm-ups that we'll do the following day, and then the homework that night. Obviously, we'll do a quiz review that also has that stuff in, but you want to make sure that you don't get confused when you start looking in your book and there's no R. It's because it's not there, okay? Today, we're going to talk about rectangular coordinates, okay? Remember, I told you you get to feel like a genius today. So the coordinate plane, which is also referred to as a Cartesian plane, because your homework will say graph it on a Cartesian plane. Those are the same things. Has all these parts, right? So horizontal axis is your x-axis, vertical is your y-axis. Where they meet is the origin, and then your quadrants start in the top right quadrant. That's 1. Then go counterclockwise 2, 3, and 4. Everybody remembers this stuff, right? Told you to feel today. Okay, plot your points and label your quadrants. So plot the points, give them their names so that you know where they are, and then state which quadrant they are located in. All right, so point A, 2, 3 is 2 to the right, 3 up. Point B, negative 3, 2 is back 3 up. Back 2, up 3. C is to the right 2/3, so this is an approximation, doesn't have to be exact, down to negative 3. D is 0, 3, so you don't go left or right at all. You go up 3. E, negative 3 means back 3. You don't go up at all. And then F is 0, 0, right there where they cross. So if you were to label or to give the quadrants, what quadrant would you have said that A lies in? Quadrant 1. Good. How about B? Quadrant 2. How about C? 4. How about D? Trick question, right? What do you call that location? The y-axis, that's what you write it as. So it is not a quadrant, but the y-axis. Negative 3, 0 would be? X-axis, and 0, 0. Good, origin. Questions so far? Not to burst your bubble, but that's probably not a quiz or test question. This is just the foundation for moving forward, okay? All right, so some application of that. Determine which quadrant or quadrants satisfy the given information. So if you look at A, it says X is greater than 0 and Y is less than 0. So if you need the visual, give it to yourself, okay? In this coordinate plane or Cartesian plane, where is just the X greater than 0? So just look at that first part. Where are the X values greater than 0? Quadrant 1 and 4, right? So the right side of my coordinate grid. And then the and means that both of these have to be true, right? So where is the y greater than 0? Or sorry, less than 0? It'd be 3 or 4, but because we're saying and, right, we're looking at just where they overlap, which would be quadrant 4. Good so far. B says X times Y is less than 0. So less than 0 means negative, right? How is the product of two numbers negative? One's going to be positive, one's going to be negative. So again, if you think about what happens when you move around your coordinate grid, the first quadrant, they're both positive. Second quadrant, X is negative, but Y is positive. Third, they're both negative. And fourth, the X is positive, the Y is negative. So which of these quadrants is going to give me a product that's negative? Good. So sometimes there's more than one answer, thus the quadrant or quadrants. Sometimes there's only one. Okay, scatter plots are in this section. So a scatter plot is a way of showing results from data, okay? In a scatter plot, so this is just an example of one, but in a scatter plot, you would have started with an XYT chart, okay, where it's either vertical or it's horizontal. It doesn't matter which way. It could either be that or it could be that, okay? And the X values, or the left side of your T chart, is going to be the horizontal or the X-axis. So this would have been hours of study if I was to compare it to what was in this chart. And the Y is going to be the right side of your T-chart or the actual vertical, which in this case would be the scores. So this is already done. Each coordinate point in this box would be plotted, and then you would just look at the overall data. So you want to make sure that you're consistent on your markings, like these went by 5s on the bottom and 10s on the top. It doesn't matter which way, as long as you're consistent. And then usually standardized tests love this stuff. They usually ask you to infer something about that graph. So if you were provided that graph and asked, what can you infer about this data, what could you tell me? Mm-hmm. So apparently, according to this data, the more hours of study that you do, the higher your test scores. That's a positive correlation, okay? What happens at the end of this data? What happens to these two?
They probably study too much.
Okay. Have you ever been like reading for so many hours that you don't know that you're alive anymore? You have no idea what you're reading, right? Sometimes there's something called too much study. Around this appears about hour 26 and hour 30, you become less productive, okay? So, but when you're asking for like an overall trend, this has an overall positive. You kind of can ignore some of those outliers. This would be an overall positive correlation. All right, your turn. So here's the data, a chapter, 1, 2, 3, 4, 5, and then the class averages. Take that data and put it into your scatter plot. Make sure that you label your axes. Make sure you are consistent on your increments. All right, so the overall shape of your data should appear to be similar to this. It doesn't mean that all of your increments and everything are the same. But you should have had chapters on the bottom because the left side is your X. You should have had class test average on the left going up because that's the right side of your chart, right? So if you were to map it out, if you think about it in advance, you definitely want to plan it out before you start drawing. You should have seen the lowest score was 79, the highest was 87. I don't want to start at 1 and go up by increments of 1, okay? You can jump as long as you're consistent. So I jumped and marked that my lowest was 70, and then I went up by 5s. On the bottom, I went by 1s, okay? So what's the overall trend of this data? It's decreasing overall, yeah. It goes down a little bit, comes back up. But if from start to finish, if I were to draw, this is actually called a line of regression. If I were to actually draw a line of regression, you would see it be not too steep, but it is decreasing. Do we see that? So that means it's a negative correlation, which means what in terms of this data?
As the chapters go on, they get worse scores.
Okay, so it appears as though as the chapter goes on, the class average lowers. There's a lot of stuff that can be read into that, okay? You could say that the actual material gets harder. You could say that if chapter 1 was first quarter and chapter 5 was last quarter, maybe they've started to slack off at the end, that kind of thing. There's a lot of stuff you can infer by it. What happens around chapter 3? There's a serious dip, right? So again, you could make up all the stuff you want about it. Chapter 3 is the hardest. Chapter 3 is around homecoming week. You have no idea, right? So you just want to do an overall trend. And when you get a question based on data on a quiz or a test, and it says what inference can you make, you want it to be specific to the data. You don't want to just say this has a negative correlation. You want to say that the relationship between the chapters and the test is a negative correlation, which would imply that the higher the chapter number, the lower the average. So you want it to be specific to the data. Does that make sense? Okay, you don't want to just say like, oh, it has negative correlation. All right, 2 formulas you've got to know, which are distance and midpoint. You've seen these lots of times. Sometimes we need refreshers. Distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. This is oftentimes also referred to as length of a segment connecting 2 points. Okay, and it is one number, okay? It could be a square root or it could be a simplified square root, but it is just a single number. And then the midpoint is x1 plus x2 divided by 2, y2 plus y2 divided by 2, and it's going to be kept in parentheses like that. This is an xy coordinate, so your answer is always going to be left in xy. All should be simplified, so it's fractions, they should be simplified. They can be kept improper. They don't have to be put into mixed number form, but they should be simplified. And your square root should be simplified. Anybody still copying that down? All right, so here's the application. Find the distance and midpoint using the given points. I'll do A with you, and then you'll do B by yourself. So A's distance, okay, I need x1, x2, y1, y2. Does it matter which ones I make which? As long as I don't mix the numbers, it doesn't matter. So this could be x1, y1. This could be x2, y2, as long as the numbers sit together, right? So this is the square root of 4 minus a negative 3, which becomes plus 3, squared, plus 2 minus 2 squared. I get the square root of 7 squared, plus 0 squared, square root of 49, which goes back to 7. So there's the distance or length of the segment connecting those 2 points. And then the midpoint, I would do negative 3 plus 4 over 2, 2 plus 2 over 2. That's going to be 1/2, 4 halves, which I'm going to simplify to 1/2 and 2. And then you do B. You should have gotten square root 10 for your distance and then negative 3 halves and 7 halves for your midpoint. Again, you can convert that into mixed number. It could have been negative 1.5 and then 3.5, or you can leave it as it is as long as it's simplified. And be careful with your square roots. Like if that was square root 20, I would expect to see it be written as 2 root 5. So if you're unsure, use your factor tree, see if it can be simplified. This seems silly, but every single year, at least a handful of people switch the signs between the plus and the minus between distance and midpoint. So be careful, okay? Within the parentheses, you're subtracting on distance, but then you're adding the adding the squares. And then with midpoints, you're adding. So just be really careful. You don't want to get things wrong because of silly stuff like that. Practice is the best thing for it. Questions on that? Okay, now coordinate problems. So what's the application of that stuff again? One way is to verify types of polygons. So if I told you that something's a triangle and I wanted you to verify it was a specific type of triangle, you can get one of these 3 cases. If it said to verify that the triangle was a right triangle, then I want to show that the side lengths fulfill a squared plus b squared equals c squared, or the Pythagorean theorem. If it wants you to verify that a triangle is an isosceles triangle, it means 2 sides have to be the same. So you're going to find the distance formula. You're going to show that 2 sides are the same. And if it's asking you to show that it's an equilateral triangle, you're going to find the lengths of all 3 sides and show that they are the same. Now you will see 2 different types of problems within this case. One is where it's telling you it is one of these 3 types, and you just have to verify. And for that, your work is going to prove that it is. So you need to show your work. The second is, here's 3 coordinate points. Find the lengths of all 3 sides, and then classify it. Is it right, isosceles, equilateral, or neither? So for that, those you're showing, obviously, you're finding the lengths of the sides, and then you're going to classify it. So those are 2 different types of problems. Both of them require work. So on homework, obviously, there's not work on plotting points. There's not going to be really points on the work on the application to it. But I better see work on distance formula, midpoint formula, and then the coordinate problems. So those will look something like this. Use the coordinates A, B, and C to show that triangle ABC is a right triangle. So my advice is to start by graphing it because it's going to help you narrow down which points you're trying to prove, okay? If the coordinate points is 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, that's A. B is 6, 0. C is 2, 0. Here's my triangle. First of all, does it appear to be a right triangle? Yes. Is just drawing it enough information to prove that it's a right triangle? Nope. Okay? So you're going to find the lengths of the sides to prove a squared plus b squared equals c squared. Now which one, it doesn't matter which side's a and which one's b, right? But c has to be what? The hypotenuse. How do I know what the hypotenuse is? One opposite what appears to be a right angle. So it looks like it's this, which means that AC is what we're going to assume is our hypotenuse. Which means I can either do AB or AC or BC or BC or AB. It doesn't matter the order there. I just need AC to be by itself. Okay? So now I got lucky this time intentionally. And the lines are horizontal and vertical for 2 of the sides. So you can literally count the distance. 1, 2, 3, 4. This side length is 4. Vertical 1, 2, 3. That side length is 3. So I get 3 squared plus 4 squared equals. The last one is not vertical, so I got to use the distance formula. AC is equal to the square root of 2 minus 6 squared plus 0 minus 3 squared. Negative 4 squared plus negative 3 squared. 16 plus 9 square root 25, which is 5. And then I get 9 plus 16 equals 25. 25 equals 25. Yes?
Since, like, you know, like, I could, like, know my
Triples.
Do it, I need to show, like, all that still, or?
You're not going to get a triple. Yeah. I'll force it so it's not a triple. So, good question. Okay. You would still have to show that 3, 4, 5 works in that equation because that's how you verify. But you should know going into it, like, if this was a question to say, what type of triangle is it? And you say that's 3 and that's 4. You could say, oh, if it's 5, it is a right triangle, but you still have to show the steps to verify it. And most likely on your quiz, it's not going to be a triple, so that you have to do the work. Questions? So again, this part said show that it is. It already told you it was. I knew it was going to be. The other type of question is going to say here's 3 points, classify it, where you're going to find the 3 lengths and then figure it out from there. So you're testing right isosceles or equilateral. Any questions on what we've covered so far? Okay, this next part I don't need you to write down, but because I'm going to share with you information, okay?